Hi everybody, my name is Steven. Welcome back for another video. Today we're going to talk about using PCA9685's to control LEDs. We'll show how to use basic LEDs with the basic on and off commands, and we'll show how to use it with signals. In my case, I'll use it for block signaling on multiple blocks I have on this layout here. So hope you enjoyed this and find it useful, and let's get started. Okay, let's talk about controlling LEDs in DCC-EX using the PCA9685. What we're going to do is we're going to show what the PCA9685 is, how we wire it, and how we address it. Now this is the I2C addressing. And we're going to talk about adding the PCA9685 to DCC-EX so that the command station recognizes it and knows it's there. Then we'll talk about defining LEDs in DCC-EX and what we need to do there. Then we'll show using the set and reset command to control the LEDs. This is basically the on and off. And then we'll talk about fading, so doing just that, being able to fade the brightness of LEDs. Then we'll give a demo. We'll show the set, reset, and fade commands all in use. And then we'll come back to the Arduino IDE showing how to define signals in DCC-EX. We'll be looking at 2 and 3 aspect lighted signals, how to control them using the red, amber, and green commands in DCC-EX. And then once again, we'll give a demo. This time we'll actually show a train going through a block detection area and changing the colors that'll be for a signal. All right, this is the PCA9685 board. It's a 16-channel 12-bit PWM controller. So the 16-channel refers to the 16 outputs. You can see the pins for them along the bottom. 3 pins for each output. The PWM, the voltage plus, and the ground. Excuse me. So for the LEDs, we're just going to be using the PWM and the ground pins. And with that, there is resistors for each PWM pin. So we do not need to add resistors for the LEDs. They have them built in through this board. Okay. These are addressable. You can address up to 64 of these, which would give you 1,024 controllable addressable pins. Now, when I first started learning about doing this, looking on DCC-EX, they referenced 62 boards of addressable. I don't know if that's a limitation to DCC-EX or there's something that I'm missing. But even if so, that's 992 controllable pins that you could have. I don't have anywhere near that many boards, so I don't know what the difference is going to be and whether 63 or 64 will work. If we ever get there, we'll figure it out. All right, as far as for setting it up, there's 4 wires that comes off of the Mega to address or to control the PCA9685. And you can daisy chain these together and add multiple boards, as we mentioned. And doing so is just a matter of running the wires from one to the next. It doesn't matter what side you go in or out of. The pins on the left and the pins on the right are the same. And you can go in or out in either direction. All right, so to make the connection, since we're driving LEDs, we're going to be using the 5 volt to the VCC pin. This powers the onboard chip, but it also powers the LEDs through the PWM pins. We won't be using the V plus pin for LEDs. We're actually going to use it. I'll explain that in a second. But the V plus pin is tied to this external port for an external power supply. And that powers the red pins in the middle, which is what powers the motor on the servo. Because the servos draw too much power, too much current, we wouldn't want to use the Arduino for that, so we put an external power supply for that. And that's what this shows. We're going to be, we will have a servo connected at one point, and so that's where the power would come in from. Okay. Next, we need to be able to address these, and we do that through I2C, and it uses a data and a clock pin. So the data pin we're going to connect goes on pin 20 on the Mega. And the clock pin goes on pin 21. Easy as that. Just a wire from pins 20 and 21 to the data and clock pins on the 9865. Next, we connect the LEDs. The anode or positive will go to the PWM pin, or the yellow pin on these boards, and the cathode or negative will go to ground. Okay. Next, if we're connecting multiple boards together, just as I mentioned, you just run from one board, the 4 wires, to the next board. Now, if you are running servos, you can take this power and it will go out the V plus and run that to the next board. So you don't need to connect to every external power supply. Just run one wire from here to the next board and it will send that current. And you would use this, you want this external power supply that's going to be maybe a couple of amps to be able to drive servos, just like I said, because the board can't handle that kind of current. All right, so these are the address paths. This is how we use the I2C addressing for the boards. You can see there are 6 sets of paths, and we do it by you just put a glob of solder on the paths, between the 2 paths for each address pin. You can see these are open, these are blank, and this one is connected for that first path. The addressing is here, and I will put a link to this in the comments below so you can get this and have it available. But you can see the first one with nothing connected is 0x40. The one in the previous picture with the first pin is 0x41. Now these 2 boards are predefined in DCC-EX. So if you're using up to 32 pins, they're predefined. All you need to do is put the glob of solder on the second one to change its address. Anything more than that is when we need to address it in DCC-EX, and we'll get to that. All right, so this is kind of just a base rough drawing of what it would look like, and you can do LEDs and servos on the same board. So you've got a servo, it's got 3 wires, and they're typically color-coded, orange, red, black, or white, red, black, and the white would go to the orange or yellow pin. Otherwise, it's pretty simple. The LEDs, from the PWM to the anode positive of the LED. The good thing is all the negative, all the ground stuff is common ground. So if you've got a bunch of LEDs that are a couple of feet or several feet away from where the controller is, you can run a single ground and just tie them together on any one of the ground pins, and it will work fine. And going through the second board, it's all tied to the common ground, so even multiple boards are all tied together. And so it reduces a little bit of the wiring by having just a common ground. All right, let's now talk about current limit and driving LEDs from the Arduino. So if we're using the VCC pin, it is going to limit how much current we have available. If you're connected to the USB port, which is how you upload your sketches and program, it's limited to only about 500 milliamp. And you do have overhead, so you've got the processor on the Mega itself. If you've got Wi-Fi, you've got the Wi-Fi shield aboard. You've got the motor driver board, the processor on it. You have other things connected to pins on the board. All those things, take away some of that power limit that you have available. So you get rid of that overhead. If you've got maybe only a couple of 100 milliamps available, well, the output from the 9865, because of the resistors that are on it, limits the output to about 10 milliamps. It's plenty enough. The lights, the LEDs, bright, light up bright. They're full brightness. They're good. It's plenty. But so at 10 milliamps, you figure even at a 200 milliamp available from the port, you can do maybe about 20 LEDs, but that's about it. So the next option is the barrel jack. 7 to 12 volt is okay, although technically it can take more than 12 volt. It really starts generating heat, and you don't want to do that. In fact, the recommended voltage is about 7 volts. You do have overhead, you do have some voltage drop through the voltage regulator, so the 7 volts will give you the 5 volts you need to power everything without generating too much heat. And that's just it. Anything over 7 volts, it just gets wasted in heat through the voltage regulator, which can reduce the output ability of your VCC pins. So with that in mind, with a 7 volt power supply, the ratings for the board listed at about 800 milliamp. I've seen a couple of references say as much as 1,000 milliamps or 1 amp. So take that as it is. I'm kind of being cautious, saying you got about 800 milliamp available to go that route. So quite a few more LEDs, but still some limit. The next option is to use the voltage in pin. Caution with that, it's not polarity protected. So if you cross wire these, you can blow your board. But otherwise, same recommendations. 7 to 12 volt, okay. Recommend 7 volt. It goes through the same voltage regulator, and it gives you the power limit of about 800 milliamp. Where this is neat is that the new motor driver through the DCC-EX team provides power to the Arduino board, and from the comments that I have received from them is that it's they thought about 2 amps of power. So it's plenty to drive this 800 milliamp available out through the voltage regulator, because that's what you're going to actually end up with. It does offer more for the input from their board, but it's you can't do anything with it. So the next and final thing, and before I go to this last one, I just want to make sure that you understand I am not an electrical engineer. I do try and read as much information as I can when I prepare for these videos. I've tried to read through data sheets and reports and everything, or comments, everything that I can find on this. This is just, I can deal to the best of what I can do. All right, so I'm talking about connecting direct to the VCC pin on the PCA9685. Now, I know you can do this, and it's okay. The input on that is good for up to about 5.5 volts. So you can connect 3.3 or 5 volt power supplies, you'll be okay with that, and it will work. But make sure you use a well-regulated 5 volt power supply because it is good up to about 5.5 volts, and if you start getting above that, you risk damage to your board. In this case, your power limit should be determined by the attached power supply. So instead of the VCC coming from the 5 volts on the Arduino, it's coming direct from an external power supply. Now, I didn't show this in the original picture, but just picture the wall wart is going to the green headers for the servos, but another one going to the VCC pin for powering the PWM pins for LEDs. Just be careful with what you do for this, and it should supply that power, that current available to all the boards down line. So this would give you the ability to attach multiple boards together with enough current to be able to drive more than 30 or 40 LEDs. Again, I'm not an electrical engineer. This is just so that I can figure out to the best of my knowledge, and if somebody wants to chime in and let me know otherwise, certainly put it in the comments. Anyway, that's all that there is to it. We're going to now move over to Arduino IDE and start looking at how to make all of this work.
Okay, in this lesson, we're already assuming you know how to use the Arduino IDE, make changes to your sketches and upload it to your command station hardware. I'm not going to cover over all that here. What I just wanted to go over is the first thing you need to do is go to the folder where you have the command station sketch stored. In my case, I changed the name of it, so I've got it under different folders called CS Test LED, just for showing this example in the LEDs. And you're going to scroll down to this section here. You're looking for this myhal.cpp_example.txt. So that's a text file, and it does not compile in Arduino, and we need to use this file. That's how we address the PCA9685's. Notice that there is another file in here called myhal.cpp.txt. Not that one. We want the one that does say _example. Now I'm going to make a copy of this just because if I mess something up, I can come back to this. And so you can see I've got the copy down here, and I'm just going to rename this, and all I want to do is take out everything after .cpp. And it's going to ask me if I want to change the file name extension. The answer is yes, I do. So there's the file, and that's what we're going to use to make the changes in when we get over to Arduino IDE. So we're going to go over there now and look at this, and we'll go on from there.
All right, so we're in our Arduino IDE. And we've opened up our command station sketch, and if you look across the top, you see all these little tabs. That's all the different files that are part of the DCC-EX command station. And over to the right, this little down arrow drops down. You can see there's actually lots more of them. There's quite a few in here. And we're going to go and check out that myhal.cpp that we just renamed and basically created for the DCC-EX command station. This is where we'll define the PCA9685's. So in this version, it's down at line 92. So if you scroll down here, you'll get to the section for defines for the PCA9685 PWM servo driver module. So as I mentioned in the beginning of the video, there are two of them already predefined in DCC-EX. They're actually defined elsewhere, but they are defined in the system under the I2C addresses of 0x40 and 0x41. And that's what this little number is here, is the addressing for it. This is the line that defines the PCA9685 so that we add a third or fourth or whatever. It's commented. These two slash are comment marks, and so they don't actually execute. So by removing those two, we now have an executable line of code or command that will work in the system. So here's the command, uppercase, PCA9685, : lowercase, create. And in parentheses, this is the some of the definitions that we need to put in, the parameters. So the first number is the first pin. So if you remember on the picture of the PCA9685, there were 16 sets of pins along the bottom. That's your PWM output pins for driving the servos. The first one on the bottom left on the default slot defined at 0x40 is pin 100. Then the number of pins, we know that this is a 16-pin controller. And then the I2C address, and the first one is 0x40. That's predefined in DCC-EX. So because it's 100 inclusive, the numbering for those pins is 100 through 115. So the next one would be pin 116 for 62 pins. I'm sorry, for 16 pins on address 0x41. This one is also predefined in DCC-EX, so we don't need to do it. If we add a third one, so 16 pins from pin 116 gives us pin 131. So the next one that we want to define is pin 132. So if you're adding your third one, this is where you could start, pin 132 and 0x42 on the address. So that would be the command that you make to add another PCA9685 in sequence. So this first number is the first pin on the PCA9685. It's 16 pins, and then that's the address. So the next one, 132 plus 16, gets us to 147. So if we addressed a fourth one, it would be 148 as the first pin. Now, you don't have to go in sequential order here. You could go and skip ahead. Let's just copy this and paste it. It'll be a little bit easier. You could skip ahead, and let's say we want to do pin maybe 300, and we'll give an address of 0x43. The reason you might do that, maybe you want your servos under pins 100 through 199. You want some basic LEDs at pins 200 to 299, and maybe you have some signal LEDs that you're lighting up, which we will get into in this video. Well, maybe you want them starting at pin 300 to 399. It gives you a way to be able to categorize your pins into different lots. You can do this. You don't have to. You could go on this next one straight to 148 and create the next one and just do it numerically, sequentially. Your choice. So we've got two PCA boards defined here, and they will be ready to go in DCC-EX with these commands. Now in this tutorial, I actually will not be using these. I'm just going to be using the default, the first board that's already predefined in. But I do have on my main layout multiple boards, and I need these extra addresses, so I've added some of these into it to be able to use it. But for this demo, we're just going to be using the pins 100 through 115. We just don't need that many. All right, so that's how we get the PCA9685's defined in DCC-EX. All right, let's talk about defining LEDs. By default, in the original instructions I was looking at, I was reading that I had to define the LED for every one that I wanted to control. But in experimentation, that's not the case. If I want full brightness, I don't need to do anything. It'll turn on and off to full brightness. And I can still use the fade command, which we will get to later on in the video about not having to use full brightness. But there may be situations where you want an LED set up where it only works at partial brightness. Or you may even want to invert it where it comes on at a dimmer level and goes off at a brighter level. Well, you can define that. You can tell DCC-EX some definitions for the LEDs. To do that, you may already have a My Setup in here. Now, I'm doing this from scratch for this, so I don't have one. So you scroll all the way up, there's a new tab command, or Control-Shift-N will give us the new. And in here, at the bottom, we're going to type in the name, mysetup.h. Oops, I missed. mysetup.h. And you can see the setup is capitalized, the S is uppercase. Click OK or type enter, and it brings us to a new tab, a new page, when we're in the My Setup file. All right, so I'm going to paste what I have something already ready to go here. This first line, if you're interested in that as well, I'll cover it since I put it in. This turns track power on at startup. So every time you power up the DCC-EX command station, it will turn on track power. If you don't want that, if you want to manually turn on track power, then just don't put that in your setup file. Below that, this is the commands for defining LEDs in DCC-EX. So this IO device configure servo, look at this capitalizations, the uppercase, lowercase, and then you've got the V pin, which is the pin that the LED is on, the on value, and the off value. So the V pin would be the pins defined on the PCA9685. So we've got the first two boards already defined, pins 100 through 131. So we're going to be playing with that one. I'm going to leave 100 just to go as full brightness. But the second pin, pin 101, I'm setting a value of 2048. So this can be anywhere between 0 and 4095. It would be full brightness. The third number here is off value, what it's going to be when you turn the LED off. In my case, I want 0 because I want it to be completely off. Then I've got one defined on pin 102, a lower value of pin 1000 and an off value of 0. Then on pin 103, I've actually got it inverted where I've got a dim 500 when it's turned on and a full brightness when you turn it off. So you can do that. Maybe you've got something where you've got lights that alternate. You turn one on and off. You could do it at the same time, just inverting the commands. And let's get the digits right. So 4095 is the full brightness. Okay? So you can change that around. You can do different things on what you want LEDs to do. That is how you define LEDs. You do it in the My Setup, and there's the command to do so. But again, if you're just using on and off with full brightness, or you want to use the fade command to control the brightness, you don't have to define them at all. Alrighty, let's see if we can control these LEDs now. Automation is done typically through the myautomation.h file. If you've seen any of my other videos, particularly one that I did specifically on compartmentalization, I break everything out. I don't leave it all in this main folder so that it doesn't get all so cluttered. So I created another folder, and in this case I called it myautomationled.h. And this is just where I'm putting some commands for this test because I know this is where I want to do some stuff for playing with LEDs, and it's just for this example here. So you can create it with the same way we did with the My Setup. Just create a new file, my automation, whatever you want to call it, led.h, and then you can compartmentalize your scripts into this. All right, so let's see what I've got. First one is an automation number 200, and it's called LEDs on. In parentheses, that's what will show up in Engine Driver, so you can select it. And then the commands to turn on the LEDs are set. So you can see I've got set 100, set 101, set 102, set 103. That'll turn on the first 4 LEDs on the first PCA9685. And then when I'm done, finished, I have a done command that tells it, okay, we're finished with that command. So that set will turn them on. Then I've got another one with LEDs off. The command is reset. So reset 100, reset 101, reset 102, reset 103 will turn those 4 LEDs off. I'm done, it will finish the command. So that's it. 2 buttons that'll be on Engine Driver will turn them on and off. Set to turn them on with the pin number, reset to turn them off with the pin number. Okay? The next thing we can do is fade LEDs. So I mentioned that if they're full brightness, you don't have to define them. So this would save you some steps of not having to define. You can use the fade command. So on that one, the command is just that, fade, the pin number, the brightness you want it to, and the amount of time in milliseconds it takes to fade up or down. Okay, so I'm doing the first one, fade the first pin, which is a full brightness pin, up to full brightness in 4 seconds. Then I'm going to delay 2 seconds, and they're going to fade it down to fade the same pin, pin 100, down to 0, so to turn it off in 1.5 seconds. Okay, so that's all the fade command is, to tell it the pin number, the brightness level you want, and how long you want to take it to get there. So then I'm going to delay a few seconds and then turn that same pin back on to a lower level, pin 1 to a 1000 brightness in 3 seconds, delay, and then turn it back off in 2.5 seconds. Okay, that's all there is to the fade command. And if you want it to appear more instant, like a light, well, change this brightness to maybe 10 milliseconds. Something sort of light up real quick. Just playing with the time there on how fast you want it to go to brightness or dim. All right, so that's the 3 commands that we use to control LEDs, and we will demonstrate that. What I want to show next is how I use these in one of my situations. So if I throw a turnout, I can have an LED light up to indicate the position of that turnout. So I created this sometime instead of an automation, it's a sequence. So it works in the background. You don't actually see it in engine driver. And I have it auto start because I always want it watching. Anytime I throw the turnout, I want it to change the light, the status of the light. Okay, so the sequence is basically it's an automation that doesn't show up in engine driver. It works in the background. Auto start makes it run when the command station starts. So turn 1 is an alias that I've given to turnout number 1, and it's on pin 115. You could do that too. You could just type in 115 and use the pin number. I use aliases a lot, and I did in this case for it. So all this does is if thrown, so if turnout 1 is in the thrown position, or if pin 115 is in the thrown position, then set pin 114, which is an LED I've got set up for the example in the pin right next to it, just to correspond with the turnout. And I'm using servos to control the turnout. See, these are servo turnouts. I guess I didn't say that. So again, here we go. If the turnout gets thrown, turn on the LED associated with that pin. I need the end command, end if command, because I've got an if statement in it. And the follow 202 just tells it to go back and continue to loop and continue to follow this. So every time that switch gets thrown, it will light up the LED. My next one is sequence 203. It's the same thing except if closed. So when the turnout, that same turnout is closed, it resets pin 114, the LED associated with that. All right, so you close it, turn off that LED, end if and follow. So again, it continues to loop through. One more thing I'm going to demonstrate, and this is actually on the DCC-EX website, and they simulate a campfire. And that's what we're going to do here. So we're just using a bunch of fade commands. So fade, in this case, will be pin 103. It'll pin one that'll have set up at full brightness. But we're going to only fade it up to a brightness of 150 milliseconds. Then it's going to delay random. So it's going to delay between 200 and 800 milliseconds. Then it'll go to the next step, which is to fade that same pin up to a brightness of 530 milliseconds. It's going to delay again randomly between 200 and 1000 milliseconds, or 1 second. Then it'll go to the next command where it'll fade the same pin again down to 75 in 75 milliseconds, delay a random amount, and continue to do that each line. So each line basically telling it to fade pin 103 up to a different brightness at different times of ramp time, and then to delay a random time in between each. So it's supposed to give a more random, realistic flickering effect of a campfire. And so that will show up on my engine driver as called campfire, button called campfire, and we'll be able to see that. So that's the first 3 or 4 things we want to look at just for turning LEDs on and off. So we're going to go ahead and do a demonstration of that, and then we'll come back and look at doing signals. But before we can get to the actual demo, there is one last little thing that we need to do. So since we compartmentalize this, we put it in its own folder in the myautomationled.h. I have to go back to the main myautomation file, myautomation.h, and I have to include it in there so that the system knows about it. So as simple as that, a # include, and then in parentheses the name of the file. You can see some other things that I've got set up in here that I'm using for different things, and we'll get to the signals later. But anyway, the myautomationled.h is now into the here, and it will compile and work properly. Then all we need to do is I'll make sure I've got my board selected, I've got my COM port on, and then we upload it to the sketch. So it's going to compile a sketch, and then upload. Okay, it's done uploading, as we can see down here. So now it'll be ready to use. I will get set up to do a little demonstration, and I'll come back to do that to show this the first step of turning LEDs on and fading them. So I'll be right back.
Okay, so let's show this working with the set, reset, and fade commands. So just what I've got set up here, underneath this green board is my Arduino Mega. This is just a terminal board that I use. It's got screw terminals for permanently mounting wires to. I'm not actually using those at this moment. The only reason I'm using the board is that it's got a plug on it for directly plugging my Wi-Fi module into for connecting engine driver. Just makes it easier for all-around connection. Then I've got the 4 wires coming to the first PCA9685 address 0x40 as defined in DCC-EX. And then it daisy chains to the second one, 0x41, also predefined in DCC-EX. This is where my wall power is powered to for the 5 volts that drives the LEDs and the servos. So I only need to connect in one place, and it doesn't matter which one, I've got to connect to the middle one. And then wires coming up to the third one. Now, this is one that I've added and addressed in the myhal.cpp file. Its address is actually 0x44, it's just one that I had. And I've got plugged into it a servo. So for like a servo controlled turnout, and an LED, which identifies the open or closed or thrown position of the servo. And right now it's in the closed position. You'll notice there's no ground connected here. And on this second board, which has 2 LEDs connected to it, there's no ground connected to it from all the LEDs, the common ground from all the LEDs. And I talked about that in the beginning of the video, that you can, multiple wire LEDs together with just a single ground. It goes to the first board. But because of the common ground and the ground running between all the others, that's the only ground wire that I need to connect up all of these LEDs. So it makes wiring a bit less messy and easier. You don't need as many ground wires running. So from that, we go to engine driver. And I've got the roots pulled up with those automations. If you look there, you see A205, A204, A201, A200. And the A stands for automations, and that's those 4 that created. The LED on will do just that. It will turn the 4 LEDs on, even though they're on different boards. Okay, there they go. Now, in the video, it's hard to see, but the yellow and the first red are dim. They are less than full brightness. It just doesn't show real well on this video. And then, of course, when we hit turn it off, that's the reset command that turns them on. So set, reset, turns them on and off. Now we do the fade. I realize there's flickering on that as it fades in and out. That has to do with the frame rate of the video and the refresh rate on the LED. To the naked eye, it is not flickering like that. It's a nice smooth fade in and out from off to its brightness level. And then it fades down to 0 slowly, and then it should fade back up to brightness and then fades back down. Again, I apologize for the flickering in the video, but it just has to do with the frame rate on the video showing it up. And that's going to be the same problem when we do the campfire, which is the random flickering. It's actually flickering more in the video than it is to the naked eye, but you can imagine that under in a firebox or under a log or somewhere, simulating a campfire or some sort of flame flickering. And that's what that little random fade command did in that automation we wrote for that one. And the last thing I want to show is, in this case, we've got the servo and the LED on the same board next to each other and the pins next to each other. So when I go to my turnouts and I throw that turnout, you can see the arm move as if we're throwing the turnout and the light comes on. And then closing the turnout, it turns it off and moves the arm back. So you can put these next to each other on a PCA9685, and if you wanted to do that, and you could even have multiple LEDs. Maybe you have a green and a red, a green to show an open route and a red to show a closed route. Different options on how you can do it. Anyway, that's it. That's your set, reset, and fade commands, and a couple of options on how to use it, and then wired up on multiple PCA9685's. Next, we're going to go back to Arduino IDE and look at setting up signals. 2 and 3 aspect signals.
Okay, for defining signals in DCC-EX, the first thing I did is I came back to the My Setup file and I deleted those LED definitions we had in here. The definitions I had in here were to dim the LEDs, keep them from full brightness. And it may be that you want that on your signals. If they're too bright, you can reduce the brightness by defining them here. But for this example, I wanted full brightness. So I just took those definitions out so that I've got full brightness on my LEDs. Next, I created another subfolder. I'll talk about compartmentalizing. and it's called mysignals.h. And all it is this is where I define my signals for each block of my layout. Now in this case, I've only got a couple that I'm going to define. Here are the two commands that you use for defining signals in DCC-EX. The difference is signal and signal H. Signal sets the pin you're describing to low, and signal H sets it to high. Using the PCA9685 in this case, we're going to be setting pin to high, so we want to use signal H. And then we'll define the red pin, the amber pin, and the green pin. And so I've got two described here, signal H, and in parentheses, the first number is the red pin, the second number, the second set of digits is the amber pin, and then the green pin. Now, since we're only using a red and green on the first one, all that means is the amber pin will define as a 0, meaning there's no definition for it, there's no pin. So pin 100, 0, and 101 will define red, no amber, and green. Now the second one, we do want an amber pin, so I'm going to go to the next pin number, which is 102, 103, and 104. So that signal defines red, amber, and green for that next signal. So that's all there is for defining the signals. Once you have them all defined, however many you need in here, they're in this mysignals.h. Don't forget, you have to go back to my automation, the main automation file, and include it. Again, I've already done that here. # include, lowercase, and in the parentheses, mysignals.h, the name of that subfolder. So they're defined and ready to go. Now to use the signals, we're going to go back here just a second. When you define the signal, the first digits, the first pin you define is the address for that signal. So let's take the second one. You've got 3 pins, 3 sets of digits to define the signal. Well, the first one, number 102, is the address for that signal. So when we address these in our sketches, we're always going to just use 102 for the signal. So when we address green, amber, or red, it's always going to be addressed to 102. And by using the color to describe which pin we want, DCC-EX knows which pin to light up. I'll show what I mean by that here. So let's go back to the My Automation LED file where I'm doing my automations for this example. So I've already kind of commented a couple things out. I need to make the changes. So the first thing I want to do is when the system starts up, I'm going to do a sequence that's going to auto start, and I'm going to turn on my signals. In this case, I'm going to turn my signals to green. I want to show my track ready to go. And so here's the command. So I've got 2 green signals set. So green 102, that's that tricolor signal. We're using just the first pin address as 102. And green 100, that's just the 2 aspect. So we're going to set green on both of those. Okay? So then I have a layout that's got multiple blocks to it. And we are going to sense when a train runs from one block to the next. And when it enters the second block, it's going to show that block as occupied or unoccupied. It's going to change the signals based on what happens as the train crosses it. So we're doing another sequence here. We're going to auto start it because we want it to run. So at 42, at means when 42 becomes active, then it will do what follows. If 42 is not active, then it ignores everything afterwards. So at 42, when pin 42, which is one of the block detectors, goes active, it's going to set red, but we want red 100 because that's the first address that we've got. Okay? Then it's going to follow 206. It's going to keep reading this. So anytime 42 is active, it's going to set the pin, the signal to red. The next sequence, again, we're going to auto start after 42. So after means that the signal has gone active, the block has gone active, and the train has left that block and it's no longer active. So when that happens, we want to go back to green because we're just using a 2-aspect signal, pretty basic signal here. So we're going to do green 100. Again, the same number because that's the address of it, is the first pin of that signal. So we're going to turn it green to 42. Then we're going to do some more sequences. These are a little more tricky because we've got 3 signals, and there are a lot of different ways you can actually program this. Particularly if you want to have trains coming from either direction into the block to activate it. And I've only got it set up where it's going to come in from one side, activate the commands as it leaves the other side, do its thing. In this case, it's not going to work bi-directional. So again, I'll do a sequence that'll auto start at 42. So when the train enters 42, if signal 102 is green, then it's going to set signal 102 to red. Okay, remember the addressing, we're just using that first pin. So if it's green when I cross 42, it's going to set it to red. That means, oh, the track was clear, the train has entered the block, it's now occupied, so we're going to set it to red. So the next one, just in my example here, we're going to use, so the next block is on a pin 47. So when the train gets to block 47, it's actually still in 42, but I'm just doing it for this example here just to be able to make things work. So when it gets to the next block at 47, if 102 is red, which it should be because of here, then it's going to set 102 to amber. So it's gotten to the next block, the signal is red, it's going to change it to amber. Okay, so then the final one after 42, so 42 was the first block it entered up here. So after 42, it's been in 42 and it's left it, so it means that block is now clear. Then we can set signal number 102 to green. Okay, and that's it. So I have to use a little ifs, and every time you use an if, don't forget you need an end if. So I did do an if here with an end if on each one. But basically that's it. It's just a very basic example to show red, amber, and green commands changing on the signal as we go. Okay, that's all there is to it. This is ready to go. So we're going to compile it and upload it to the sketch and then do a little demonstration of it. Okay, here's a diagram of the layout that I'll be showing the demo on. Just a quick look. All the different colors are the different block sections that I have on this layout. So we're going to start with a Union Pacific engine with a couple of cars behind it on this line right here. It's going to go through this turnout. Here's where the block isolators are, so it's going to get to this next block. So this red line is the one that's on pin 42 that you saw me write about in the programming. It'll go around to the other end, go through another turnout. It's going to stay on the outside loop, and that's pin 47. So that's the 2 sections that we'll be looking at in these 2 demos to show the 2 and 3 aspect ratio signal. So I'm all set up, ready to go. Everything's turned on. We're going to start with the loco here and go forward with it. We've got this UP engine up here on the line that we're going to run through and see what happens. Okay, it's got to this block and it's set the signal to red. So it's going to run around to the far end over there. And when the last car leaves, because I do have resistor wheels on the last car for block detection. And it takes just a second after it actually leaves the block, but we'll see that. So it's getting ready to leave the block. So we'll come back down here. And as it's leaving the block now, the light turns to green. Our track is clear again. So with this basic setup here, so I've got the train stopped because I'm actually going to reverse. And when I come back, so coming in from either side, when it hits that block, it goes to red. And as it comes back around,
When it leaves the block, and it takes just a second or two after that, it goes back to green. Now we're going to change over and set up for the 3-aspect signal. Okay, now we're set up with 3-aspect on the signal. We do have green, yellow, and red. We've got our same layout. It's going to trigger as it gets to this line here and comes in over the gap there. So we've got our loco ready to go. And all right, so we got to this block and it's changed the signal to red. Now what's going to happen is the train goes to the other side up there. When the engine gets to the next block, it's going to change this to amber, and then when the train completely leaves this block, when the last car leaves this block, then it'll change to green. So as we get closer up there, we're getting close, so we'll come back over here. So as it gets to the next block, there it goes to amber. And then when it completely leaves the block, it switches to green, signaling the clear block. Now in real use, it might be a little bit different as far as for what positions you have for red, amber, and green. This is just a demo to show that it changes just based on, in this case, based on the train going through different blocks and automating the signals to come through for us. So there you have it. There is how to use signals, LEDs through DCC-EX. Hope you have found this useful, and make sure you keep watching for more videos coming soon.